Hare Krishna, everyone.
Hare
Hare
Krishna.
Hare Krishna.
Anupam Prabhu, thanks for staying so late to teach us this class. Amazing you're doing this even from India now.
Hare Krishna. Hopefully, Prabhu is still awake.
Hello,
I'm
am I audible?
100% awake. Hare Krishna. Oh, sorry, I was just
Hare
kidding.
Krishna. Hare Krishna. Sorry, I was speaking on mute. Sorry for that. Hare Krishna, everyone.
How are you,
And good
Prabhu?
morning, all of you. So I'll share the screen in a minute. Give me a second. Okay, so today we are going to cover RAG, which stands for Retrieval Augmented Generation. And I will also show one example also around which uses RAG. So shall we do the theory first or shall we look at the example first? What will all of you suggest?
I think we should do some theory so that we know the concept. And then
Okay.
that's my
Yes,
opinion.
Prabhuji. I agree.
Yeah, we will do theory first. I'll put the link to that video in the chat here. Yeah.
Welcome to.
Okay, so I've put the link in the chat here. Let's start with some theory, and then we look at the this example. Okay.
Are you sharing your screen, Prabhu?
Yeah. Just a minute. Yeah. So is my screen visible now?
Yes, Prabhu. You can see now.
Oh, great. Okay. So, like in the last two classes that we were doing, we were looking at how do we really interact with a large language model, and while doing that, how do we really write a prompt, okay, which is effective. So that prompt engineering is what was the emphasis of the last two sessions, and of course, then how do you write the code around that, and how do you select the model, which model to select. Those are some of the things that we looked at. We also, in the lecture number 4, we looked at how do we really host that type of an application. Okay, so I explained the function that we have created and what are the inputs to that function, and then like we were seeing that the input to the function is the name of the user and the name of say the Lord, okay, like the God personality that we are talking to. So we looked at all those things, and then it was giving us response as if we are talking to someone who is very well versed in Bhagavad Gita. Today, what we are going, but like when we look at that approach, uh, we are relying on the knowledge of the model itself. Okay, we are just writing the prompt, and we are expecting that the model which is there, whatever large language model that we are using, it would use the information which is relevant to Bhagavad Gita from its earlier training data, and then accordingly give us the response. But there may be a chance, okay, that the LLM is not really trained on the Bhagavad Gita related data, or it may be like it may have partial information say related to Bhagavad Gita, or say the Bhagavatam. Then how do we really solve for that problem? Okay, where we are not completely confident, okay, on the training data of the large language model itself. So that's where two approaches come into the picture, and I briefly touched upon them in the towards the end of last class, which was like either we use RAG, okay, which stands for retrieval augmented generation, or we use fine tuning. Okay. So today we are going to look at how do we implement the retrieval augmented generation framework, and what are the different components of it. So for the RAG framework, the first component is the language model itself. Okay, so you can use commercial ones or you can use open source language models. Then comes the second thing, which is the embeddings model. So remember, like in the first and second class, we were discussing about uh, having converting words or sentences into vectors. So embeddings model does the same job. It converts the text into vector representation. Now you have those vectors, okay, related to the text that you want the model to refer to. So in this case, the text would be, say, Bhagavad Gita. So all the sentences from Bhagavad Gita, you convert them into vectors or embeddings using an embeddings model, and then you store them in a vector database. Okay. So for vector database also there are different choices. Then comes the search and the chaining part, which I will explain later, okay, with the help of a diagram. Okay, so this is how, like, overall, uh, like the first three steps that I described, okay, work. So you have the source data. Now it may be in different formats. Okay, it may be a CSV file, it may be HTML file, Word doc, it can be anything. Okay. You take the text out of it. Okay. You convert it into vectors using the embeddings model. Okay. And then you store it in a vector database. Okay, so all the text that we have, say in a book, say Bhagavad Gita, we'll convert it into vectors and then store it into a vector database. Okay, now we have stored. Okay, now what will you do with this? Now our primary purpose of storing this, doing all this is that when we really ask the model a question, it should really reference the particular text that we want it to refer to, in this case Bhagavad Gita, and then accordingly respond. Right? So where would the language model go and look for the information? It will go and look for the information in the vector store. Because this is where you have stored all the information in the vector form. Okay. Now, if it has to look for that information, then there has to be some context, right? That context is coming from the question itself. Like, Okay, suppose someone is asking, okay, how to achieve moksha? Now, that question or query provides the context. Now, what we would really like is that the language model understands that query and then accordingly find relevant information in the vector store. Now, when we say understand, it won't really understand the sentence. So for it to really understand anything, it will have to convert again that question into vector. So again, the embeddings model will be used. It will be converted into a vector. So now the question that we have is converted into a vector. And all the text information that we had, it is stored in the form of lots of vectors here in the vector store. Okay. Now think of Google search. When we put a question, what it does some similarity search. The algorithm that they came up with was page rank algorithm, right? And basis that it, like in the earlier days of Google search, we used to get responses, right? Now they have replaced that with, I think, Gemini. The first answer that you get on Google search is coming out from Gemini, which again is a language model. So here also we would try to, now the onus would be on comparing the similarity between the query vector and the vectors which are already stored corresponding to the text. Once it compares, okay, whatever it finds, okay, as most similar, it is going to then find all, like, sort of extract all those text chunks, okay, which for whom the vectors are similar with respect to the query. Now, what you will get here is a lot of chunks, right? No, it can be like you may find 10 chunks which are similar, or it may be say like you find 50 chunks which are similar. Now, similarity would again have some measure, right? So similarity, so just to simplify it, like if it is completely similar, then you can think of similarity score as 1. If it is not similar at all, then you can say similarity score is 0. So we don't want any of those vectors for which the similarity score is 0. So that is one way, good way of eliminating. But what about this? Now you have said 2000 vectors for which the similarity score is lying between 0 and 1. Now how many vectors should you really consume? Okay. How many vectors or corresponding text chunk should the language model really use while generating the response? Any guesses on that? How should we go about it? I know I muted all of you because there was some background noise, but you can put it in the chat.
Can you repeat your question one more time, Prabhuji?
So I was saying, now from the vector store, you are getting vectors which are similar to the query vector. Okay, and there are say such 1000 chunk vectors which have a similarity score which are similar to the query vector. Now, how will you like really like prioritize like from these thousands which one to use, which one not to use?
Yeah, I see. Yeah, ideally you want, I mean, if there is only one, that's the best answer, isn't it? There are
But
many.
there may not be
And
many, right? Means like
yeah,
if say the question is about what is moksha, it won't be answered, okay, just from one of the chapters of Bhagavad Gita. Okay. The answer lies in multiple places. So now how do you really go about this? Like now you're getting say 1000 chunks, okay, which are similar. Now how do you cherry pick among them? Okay, suppose even say 20, okay, we are getting, so Naresh Prabhu is saying, say we are getting 20. So even when we have 20, okay, how do we sort of, should we consume all the 20 or should we
I,
filter some of them out?
Can we rank?
yeah,
I mean, based on the ranking, do we assign some scoring?
Exactly. This is what I want. This is the answer that I was looking for. So we can do ranking. Is the screen shared or it's stopped?
Stop. I mean, I can see only people's. You're not sharing.
I'll share.
Okay.
So that's where like we'll have to rank. Okay. And how will we rank? On what basis are we going to rank?
By assigning weightage or something?
Similarity score, right? Like you are
Similarity score.
comparing two vectors and you are calculating the similarity score between two of them. So you will rank order them in terms of the similarity score, right? So that is one thing, okay, that you rank order. But suppose you are getting 20 which are similar, okay, and you rank ordered them, okay, based on the similarity score. But if you'll put all these 20 text chunks into your language model, probably it may exceed the context window. I explained context window also last time, right?
Yeah.
So it may exceed. So now you want only say 10 chunks, okay. Then how will we go about it?
I guess we have to give some more information to say which ones we are looking for.
Yeah, that is
Provide
one
more
good way of thinking
context.
about it. Yeah, so you can use some metadata, right? That metadata could be, say, you would know that, okay, like uh, that for a question as broad as how to get moksha, probably say for the first two chapters are not at all relevant. So you can use that meta information. Based on that, you may drop some of the chunks, like those which are not belonging to say the chapter one and two. We'll say, okay, we can drop this. That is one way. So that is by really looking at metadata. Another is you just define a cutoff, okay, of similarity score. You say that, okay, like if the similarity score is say more than pointed, then only I'm going to consider that chunk. Otherwise, I'm going to drop it, right? So that is where this concept of top K comes into the picture. I think I'm not means I think we touched upon it last time, okay. Top K. So top K is like, okay, out of say the hundred similar, okay, vectors, you may pick say top 10, okay, or if k is equal to 10, or you may pick say 5, okay, if k is equal to 5. So depending on the top K value that you have defined, you will accordingly pick the relevant number of chunks. No, okay, we got all those chunks, okay, based on some search, okay, which is say some similarity. Okay, there are other ways of doing that search also, which is so one I described, okay, similarity, and other is maximum marginal relevance. So we'll talk about that sometime later. Okay, but okay, you got okay these five chunks, okay, which are most similar. Okay, then what will you do? Should we put them as it is in the prompt, okay, and just try to get the response? So that is actually the first way, which is tough. Okay, whatever you get, you just stuff it into the prompt. Okay, and then so if you got five chunks, okay, of text, you will just put all five of them into the text, into the prompt, along with the query, and then you will ask the model or respond. So this is one way. Okay. Then there are other techniques also: map, reduce, refine, map, re-rank. Now, map, reduce, refine, all these techniques are actually inspired from big data concepts. Hadoop, okay, in Hadoop, we used to have map, reduce. Okay. So all these approaches are actually inspired from some of the data engineering practices. So I'm not really going to explain, okay, or go into details of each of these. This is something you can do on your own. But broadly, this is what is really what defines the rag. So I'll just take a pause, okay, to see if there are any questions.
So you are saying that that 5 steps process, what you explained, is called in cumulatively called RAG?
Yeah,
Is it?
retrieval augmented generation.
Okay.
So see, we retrieved the information, right?
Mm-hmm.
And now using that retrieved information, what we are trying to do is generate a response, right?
Right.
That is why it is known as retrieval augmented generation. Earlier, what we were doing is we were just doing a generation. And in that case, we are expecting the model to really do that generation on our behalf from its own training data.
So
Okay.
for just understanding, so you the steps like at a high level, we retrieve all kind of data, transform it, and then make it to vectorization or tokenizing it, and then give it some scoring like similarity score or whatever. And then based on our algorithm, we picked based on like top K or something, which has the most score, and show it. Is that what at high level works?
Yeah, exactly. So I'll explain that with the help of this diagram once again. We have the documents, okay. You convert all of them into vectors,
Mm-hmm.
okay, and create a vector store. Okay.
So, Prabhuji, just a question. I think maybe I missed it, or you might have explained it, but just to ask, uh, what is the difference between the token and the vector, or these are same things, or?
No, they are different things.
Mm-hmm.
Token and vectors are different things. So token is something which is just sort of it's a numerical representation only, where you may use, say, uh, so first, I think it is important to understand what is a token. Okay, so what we really do, I think I have some slides. Okay, in the previous session, see if we have something. Okay, yeah, I think there is this slide. Okay, so if you look at this, okay, now in most of the cases, you are seeing that a word is actually equal to a token.
Mm-hmm.
Okay, but if you look at this word, okay, misspelled, okay, this is actually broken down into 3 different tokens. Similarly, punctuation is broken into 2 different tokens, right?
Mm-hmm.
Most of the words are appearing as single token only, but in a lot of cases, you will see that it will actually break it into 2 tokens or more.
Mm-hmm.
Now, what these tokenization algorithms generally do is, so depending on which tokenization algorithm that we are using, they would have a set vocabulary. Okay, say 60,000 tokens. So if it is finding a word, okay, which does not match with any of the token in that library, what it will do is it will try to break that word and approximate it with the tokens that already exist in that library. Okay, so in this case, maybe it had 2 tokens, punct and ovation, as 2 separate tokens. It does not have punctuation as a token in its vocabulary. So that's why it broke it into two such tokens, which are there, which are part of its token library. Okay, or the token vocabulary. Now, if this part is clear, okay, so what do you mean by tokens? Then comes the next part, okay, tokenization. Now, you have these tokens. Uh, we'll have to convert them into mathematical representation. So the easiest way is you just use the serial number. So suppose there are 60,000 unique tokens in the vocabulary. So you have 60,000 indexes. So in place of really representing them as numbers, sorry, as words or tokens, we can start replacing these with the index of the corresponding token. Then this will become just like a list of numbers, right? This will become a list of numbers. And those numbers are nothing but the serial numbers of that token in the vocabulary itself. I see a huge silence.
Oh yes, bro. So basically, it's some process which converts the token into vector, which is kind of a numeric form of the tokens. Is that, if I have to understand it at a layman language?
Yeah, so see, first step is like you convert it into tokens, then you convert them into token numbers,
Yeah.
and then you convert them into vectors.
Mm-hmm.
And that conversion to vectors. Okay, so see, I think I also described this here in the one of the classes, that like suppose you have these, like this is your word, these are all your words, okay, and say the dimensions into which you are projecting them are animal, domesticated, pet, and fluffy. So then you are converting them into vectors, okay, in a way that when you really project them across these 4 dimensions, they will approximate, okay, accordingly. So for example, like dog is domesticated, right? So it is appearing as 0.37 positive, right? Whereas rat is not domesticated, it is appearing minus 0.48, right? So you have the token numbers, then but the next thing is you need to convert those words into vectors. So that is where the embeddings model come into the picture. Okay. So that is what is done by the embeddings model, which is this. And then each word will be then stored in the form of a vector now. So it's a 3-step process.
Mm-hmm.
Now you
So,
have those
Prabhu, what
vectors.
is embedding model do? Can you repeat?
It will convert the word into vector.
Oh, okay.
Okay. Have I written it? Okay, I have not really written it. So embeddings model's job is to convert word into vector, right?
Mm.
Now you have those vectors. Now you need to store them somewhere, right? The place of
But
storing
word
them is
into vector is going through the tokenization.
no. See, tokenization is a part of the vectorization process. So you convert word into token and then token into vectors.
Okay.
That is a 3-step process.
Mm.
Words to tokens, tokens to vectors.
All that is done by embedding model.
Yeah, that is taken care by the embeddings model.
Okay.
The LLM is also doing it, Prabhu, or no?
No. LLM is
No.
separate, okay.
Okay.
LLM is separate, okay. Embeddings model is separate. Embeddings model only job is to convert word into text into vector.
So, Prabhuji, is vector is a, so I have some understanding of vector. Let me describe, see if it's correct or not. Like for example, I'm sitting in a room. So this room is a 3 dimensions. Right?
Mm-hmm.
And, in this room, so if you want to tell where I'm sitting in the room, then you have to give the coordinates of where I am right now. So this is a 3 dimension.
Exactly. So like for words also you can tell them into whatever, say and 7 dimension or n dimensions, right? That way
So
do they lie.
so basically each word is a dimension. So you have a,
Not word is a dimension.
Each characteristic.
Yeah,
Yeah.
characteristic.
yeah,
So
it's vector, even including the verbs, right, Prabhuji? Nouns, verbs, everything together. Right? And so each is a dimension. Now, if they, let's say, a cat chased rat, right? A cat chased rat. Right? So that's the way in the entire millions of, let's say, billions of words or something like that. So where does the cat chase rat falls? So is that how
no
that?
no so you are talking about a sentence, okay? I'm talking about words into vectors. So
Mm-hmm.
we would have words really placed in that n-dimensional space, not the sentences. Okay, so look at this example, okay? Like the words like cat and kitten, because should really appear close, right?
Yeah.
Okay. Similarly, like words which are anatonyms, okay, they should lie along the same line,
Okay.
okay, along the same direction.
Okay. So we define the vector each character or each word level itself.
Yeah.
Okay.
Each word is actually converted into a vector.
Okay. Then later the whole sentence converted
Now
into
the sentence is made of those multiple vectors, right?
multiple. Would they be combined into one, compounded into one?
N- Okay, let's not complicate and go there for now, because then there maths get involved. Okay.
Okay.
Okay. Just try to understand that you have words stored in the form of vectors. Okay. Because we have mixed crowd here, so I'm not really going into the mathematics. Okay. So we have words in the form of vectors and they go and get stored into the vector database. Right? Now once a query comes, we again convert that into a vector and then search for the relevant information in the vector database. For search also there are multiple algorithms. Two of them are here. Okay. Now once you have that information, how are you going to really consume that information? While feeding into the language model. Again, there are different algorithms to that. Okay. So again, like we'll just sort of recapitulate. You have the query. Query also gets converted into a vector and embedding. Then we do a search. Okay. And when we do search, okay, suppose we get top key documents. Okay. Now those documents plus whatever prompt you have written plus the query all will go together into the large language model. And then it is going to generate the response. Okay. So let's look at one some code here. Okay.
But step
Again, I
3
am
is not
talking about
clear, bro. Maybe in the example it
sorry.
will be clear. That's step 3
What which in step 3? What do you mean?
in your previous slide. That's step 3. How?
You mean this?
Maybe let's go through the example, bro.
This
Yeah,
one?
that's step 3. Yeah.
Yeah, yeah. Okay, so that's what I'm trying to illustrate now.
Okay.
So see, uh, here we are just like this is your prompt, okay, right? Okay, and then you are passing it, and this is the model, and then you are expecting it will generate a response, right? Similarly, like this is also like a prompt only, and then you are expecting it to generate a response, right? But if we do one more thing, okay, with in addition to this prompt, what we also pass is some context, okay, and what is that context? The important chunks that you got from the vector database, you pass them also here, and you add the question also. So then it will become like a composite thing that is going into the LLM. Okay, let's look at the code, okay, that I shared last time. It will make more sense probably then. Okay, so see, like this was the prompt, okay, that we were sending last time. I explained in detail prompt. And then this was the question, okay. So what was happening? We were passing the question. No, let me copy this entire thing, put it in the slide. Then we'll go over it. If we look at this, okay, this is the prompt. Now in this prompt, we were also passing what all we were passing the name of the user, the name of the god itself, okay, and then the name of the user, right? And then we were also saying like these are some of the These are the questions of the user. So you're passing that as a variable here, right? So in this case, and then we are giving it an instruction, right? Now this entire thing is prompt, and then this part is the query, right? And this is the instruction. And so even in this case, okay, what is happening? Prompt. There is a prompt without context, right? Now suppose, and here what we are expecting is it will use the relevant information in its training data and give us a response. That is what we are expecting. Now when we will do prompt with context, what we would also do is and then we'll say the context. And what is this context here? Any guesses? What is this context here?
This query.
This is the result from our embedding model, I guess.
Exactly. So
The
this is
vectors.
what the vector search like retrieval gave me, right? The all those chunks which are actually relevant to this query, right? So that is what I was saying, that the query
That
prompt,
will
which is
feed
the
only the top
instruction,
K, Prabhuji, or the entire search will
top
go?
K, only top K.
Top K. Okay.
Okay. So basis the top K, whatever retrieved chunks are there, plus the prompt, which is the
Prompt
instruction and the query,
query.
right? Here in this case, we were just passing the query, right? We're just passing the query here.
So internally, the model is getting the
And
context.
this, yeah, and we are hoping that like model has some training data, and basis that it will give a response. Now in this case, we will pass prompt with context. Okay. And where is this context coming from? It is coming from the retrieval, okay, that we looked at. Okay.
But so Prabhuji, to retrieve, first of all, we need to pass this one, right? Prompt to the system, I mean the model, and then only it gets the top K, and you have to use that in context. So when are we passing the first pass?
See, prompt is the last thing, right? Retrieval is a separate process. We did retrieval in step 1 and 2, and then we are adding the retrieved information to the prompt.
Okay. But from so we are trying to, at least I'm trying to understand from the UI perspective, right? If you open ChatGPT prompt, we just pass it everything in one shot, right?
So we are not passing any context there, are we?
We are not, yeah. So we are not passing. But
So
even to
this is what
program
we
it,
are doing. This is what we are doing, prompt without context.
correct.
We are just
But even
giving it an instruction, okay?
so, you're saying that when you do with the context, then you have to split that you're into two. Is that what you're saying?
What
So you
splitting?
give a
Split what
query.
into?
Yeah. So what I'm understanding is, so the embedding model is something that comes in between your query and the LLM. So you have the query, the embedding model has extra information from the documents that you're providing, and it searches the relevant information based on your query from that
No,
document.
no, I
And
think you
then,
got it completely wrong, okay?
oh, okay.
Okay. So what is embeddings model doing? It is just converting your like text into vector,
Right.
Yeah.
right? And then you are doing search. And basis the search, you are trying to find out which are the relevant vectors.
Right.
And corresponding to those vectors, whatever is the text, that is what you are passing here in the form of
That's
the
the context.
context.
Correct. So yeah, I got that point, Prabhu, that we break up into very different steps. My confusion is through programmatically we break this exactly what you mentioned, right? Vectorization. After vectorization, we get. I mean, once we get relevant vectors, like say top k whatever, then we use that result set in our part as a context and pass it as a prompt, right?
Pass it with the prompt, not
Yeah,
as a
pass.
prompt.
Okay, with the prompt. Yeah, with the prompt. But this is like a programmatic way. Every time we have to do, we need to do this way. Is that what you're saying?
Yeah, of course. How else will you do it?
No, for the chat GPT, how it works? Is that what your question, Pankaj bro?
So ChatGPT, I think he's saying that it's without context. That I understand. So I
But
was
but internally, it might be doing all this, right?
So Prabhu, like one question that in Chat GPT, if you are adding any document, right? We
Then it is
add the
doing RAG.
okay, that through that.
Then it
Oh.
is doing RAG. Okay. Means that is what is
Uh,
my assumption, that probably then it is
yeah,
doing RAG.
Prabhu,
okay.
maybe a basic question here. Let's say that I have a query. Hey, who is the current US president and where does he live? Okay. Where does he live is something that everybody knows he's in the White House. That could be coming from your LLM. But who is the current US president? That is something like that's not a static data. Data can change. That might something
Mhm.
coming from RAG. If I put this query in ChatGPT, somewhere down the line, a portion of this data is coming from your LLM and portion of it is coming from your RAG. Maybe that's the
Mhm.
question. I have that question. So I don't know. Maybe see, because that's the programmatic, right? Programmatic, we understand. You have a context, you can pass the context. But if I give this query without context to a ChatGPT, it's somewhere in the backend. Some system is doing this part. It's splitting the query. It's understanding what has to come from RAG, what has to come from LLM. How's that working? Maybe that will help that will simplify the question.
I did not build ChatGPT, so I'm not going to comment on that.
No, but not ChatGPT. That's an example. But any LLM prompt that we are writing. So, are you suggesting that we should always write the context with us, or it's possible that when we send it, maybe there's a service which actually gets the splits it and gets the RAG and then pass it. Is that the right way of understanding it?
What service are you referring to? When you are saying maybe there is a service, what service are you referring to?
Maybe something should be doing that in the backend. The splitting of
How do we
the.
know that?
That's
So
the question. That's what I'm trying to understand. Is that the way it works? Is what I'm trying to understand.
I don't know. Because first you tell me which service are you talking about? How can I
so I
answer
think
without that context?
Prabhuji, I think what so my request maybe yeah you explain now this is and I think we are going through theory. Maybe we should see this in a practical how so that will make our doubts clarified or queries clarified. So
Okay,
yeah,
yeah. So
we
we'll
should put
go to
when we
take a
see
look at
actually
this.
this is actually in action, then probably we can connect the dots.
Yeah, okay. So let's look at this example, okay? And this is something all of you can also play around with. So yeah, just go to this website. I think let's do it, okay, rather than looking at its video. And then just try to create a login. I'm already logged in.
Once
So this service I know about, okay. So that's why I'm making use of this as an
yeah.
example.
You want us to sign up, Prabhuji?
Yeah. So just sign up, okay,
So
using Google.
yeah, we little bit slow, Prabhu. We are trying to catch up. Yeah.
Yeah, take your time. Like it may take some time to sign up. Okay, can we go to get started?
So we need to log in as learner. So I logged in as my Google account or something, but as a learner, right?
Try login as instructor if
Okay. There are
remaining.
two options, instructor and learner. So okay,
Yeah,
instructor.
try
Oh, I logged in as a learner. Is there any way I can change, bro?
fine, no problem.
Okay.
So
Okay. Yeah.
let's click get started, okay.
Yeah.
And then we'll try to create a new course. Okay.
Create new course. Okay.
Okay. Now I'm going to upload some file here. I go to this, okay, and I'll just upload, say, my resume, okay.
Okay.
Okay. And I'm saying resume underscore. Okay. This is what I'm saying. What is now happening? It is doing vectorization, right? It is doing vectorization and storing that information into a vector database.
Okay.
Now let's go to chat with the course. Let's see if, yeah, so it shows that course. Okay. Now when I'm passing the query, who is Anupam? Okay, probably their service is not working. Okay. So what happened in the first step is we created the course. Okay. We uploaded the document. It converted into vectors. Okay. Stored it into a vector database. Okay.
Email,
Right.
and
That's,
we can set the courses
so they are also showing
created.
the same
So you
thing.
see that there is a mail
Yeah,
from
some mail
the
also comes, okay, once the
saying that
course is created.
object-oriented programming course has been successfully created. So now we have created the object-oriented programming course, which is public currently seated on a public mode. Now we'll try to make it as a private. So we make the course as private, so it can't be assigned to all users. So we have made it private. Now the course is private.
Here they are talking about features. Okay, so we'll just go to the chat part.
Role is learner.
Okay, yeah. So now
Let's
when we,
start by getting the summary of the course.
okay, this is also one option. You can
We
create
click
the summary of the
summary
course.
of the course. Here we have another feature where you can hear the received response.
Course summary for object-oriented programming. This document is about object.
Other responses.
Okay. Now when we are asking the question, what it is doing,
So we have asked the question, what are the classes and objects?
whatever chunks it has created and stored into the vector database, it is going and referring those and providing them as the context while really responding to the query. So you had this book, okay, say related to object-oriented programming. It had lots of pages, okay, lots of text. So out of those, it found the text chunks which are most relevant, parsed them along with the prompt, and then it was able to generate this response.
Sounds like
Right?
notebook LM.
Sorry?
So Prabhuji, I have a question. So
Yeah.
in terms of ChatGPT, I think yeah, in this case we are uploading the file externally, and then on top of that we are asking questions. But suppose in take an example of ChatGPT where I posted some error in my code or something and asked it, okay, can you fix this?
Mm-hmm.
And then it come up with some result, right? So this is just a normal without context, or maybe,
Right.
or is it a context? I don't know. So once it gives the step by step some solution, then I can add again, okay, can you provide this without using, instead of this you use the Java language or some other language. I give you these things, further question on the
So
result
that
set.
is just an instruction that you are giving,
Oh,
right?
that's the instruction. That's not a context. I thought maybe the result came, and that will be when I asked second time. It used that result as a context for my second question.
See, context is something which is external to the model, right? Right? Like context is something which is beyond
Yeah,
its own training data.
right. But the result come out. It's again also, see, in the model you have all vector data and all those things, and when you ask question, it simulate that result set and give you the answer. But that answer is coming out of the data in the model, but it's not like baked into the model like that completely, right? So it formed that result set. But that result set is a kind of a temporary result set is generated for us. That result is not embedded into our model or something. But again, we ask a second question.
Okay, so think of it in terms of like, suppose uh, we talk about, say, uh, we are giving, say, the instruction clearly that, okay, like you should give me response from chapter 18 of Bhagavad Gita. Okay, you're very specifically telling it, okay, giving it an instruction. Now you do this without RAG, okay, and do this with RAG, okay, you'll see the difference in the response. Because without RAG, it may not just draw the boundary on chapter 18. Because when it is doing a vector search, when it is doing a similarity search, it may so happen that for the question how to get moksha, there may be things which are also mentioned in some other chapters also. Now you are telling it to draw a boundary, okay, that don't go beyond chapter 18. But when you will do RAG, okay, sorry, when it is going to look for important relevant information in the training data, it may find things which may be coming from some other chapters also. So it may end up generating information response from some other chapters as well. But in case when you are doing RAG, okay, and in the context you just specify all the text related to chapter 18, and then you are saying, now give me the response based on this text only. Now there is no room for error because you have given it the relevant context. And now when it is going to generate the response, it is going to generate the response only using that information. Right? It does not have to really search, okay, in its training data because you have already done that job, okay, and given the model the most relevant information from chapter 18.
So when we do normal question in ChatGPT, does it go through the RAG, Prabhuji, or no?
I don't know, Prabhuji.
Okay.
So one yeah, means I can clarify one thing. So like let's say I am just giving the prompt that okay, my name is this, I am working on this, and create a letter for to my manager. It will create the letter. Then later on in the same thread, I am just asking that can you create my resume? Then it will check my older like chat and and whatever he has created, and then he using for that one to create the resume. So is this is also the example of RAG?
Like, see, like if it is using that and passing it in the form of context, then you can say it is RAG.
Oh, okay.
But if it is really updating the model itself, okay, means their model is getting updated every time whenever you're feeding that information, then it is fine tuning. Okay, but if it is just like it is storing and then trying to retrieve, then it is RAG.
Okay.
But see, that's the problem, okay, with these applications like ChatGPT, because we don't know what they're doing. Means if your personal information is becoming part of its own training data, then anyone can discover anything about you, right? Someone else can also start talking about, asking about you, and probably it will give them also the response. So it's dangerous, right?
That's scary, right?
It is.
Yeah.
Because they are not
So
really
whatever.
telling you what are they doing with your data. Are they? Has anyone really read what are their terms and conditions? Or means do we really have all that time to understand what are they writing there?
And once you feed, you can't undo, right? It's
Yeah,
permanent.
you can't. Right.
And from another question. So the context that we provide, what if it is uh, it, it can potentially create a bias or I shouldn't say bias. Like I mean, if you don't give a full enough context, then your answers can be misleading eventually.
See, that all depends on how you are like getting the context, right? So you'll have to do your diligence in terms of getting the right context.
Yeah.
Means For example, now you fed the Bhagavad Gita book and then you are saying asking it things from Ramayana. Okay. Then
But
how good
yeah.
would those responses be?
Yeah, but a different way, like for example, if you provide a context about a kindergarten book, but then ask like 10th grade math, okay, because 10th grade math probably already part of ChatGPT, isn't it? So then your answers will be more limited because you're providing a context which is sort of not as smart, as
See,
developed as
I
yeah.
think all of you are asking me all these questions in the context of ChatGPT. Sorry for
Because
that.
that's
I
the
can't
only
really
one. That's
comment
the
on
only
it.
one we know. That's why. Yeah.
Yeah.
Anyway. Yeah.
So think from fundamentals. Okay, that's what I'm trying to teach here.
Mm-hmm.
That think from
Concepts. Yeah.
fundamentals. If you have to design a system, okay, suppose it is your enterprise specific chatbot, okay, that you're trying to build, and you don't want, okay, that your information really gets leaked, okay, to someone else. Because it's very easy. You may just upload all the information in a PDF file to ChatGPT, and then it will give you very nice chat, okay. And you don't know whether it is doing RAG or it is fine tuning. You don't know that. Then that is a risk that you are trying to take, right? But if you feel that that is a huge risk, okay, then that's where you can really have RAG, okay, because vector DB is something that you can, okay, it's a database that you can keep it in your own organization, right? Even and when you are trying to generate the response, you're only passing the most relevant chunks, okay? You're not passing everything into the LLM, right? So in
Okay,
that way,
yeah.
your information still remains secure.
So Anupam Prabhu, one question. So like, are we going to cover the tagging also, like how we are tagging the vector chunk from one user to another user to just get it will be secure?
No, we are not going there. That's
Okay.
beyond the scope.
Okay.
So one question, bro.
Mhm.
So based on your example of that resume you had uploaded in that YouTube, the video you were playing.
Mhm.
So was that example for a like a context or a RAG? Like mm, when you were showing that example, like you have uploaded a file and you're searching mm, about something. So is it a context or it's a RAG? Like I'm just trying to understand.
Both are same thing, right?
I don't know. That's my question.
Because what are you doing in RAG? We are passing the context, right?
So when we use the word RAG and context, are they interchangeable words or they are two separate things?
Context passing is part of RAG.
The output of the RAG is the context. Is that right, bro?
No,
No?
not output of the
I mean,
RAG is
the
part of.
process of generating that.
See, we pass the context along with the prompt to generate a more informed response.
Correct.
So if you look
That this
at this
process,
diagram once again,
yes.
what are we doing? Here we are trying to get the context, right?
Right. Right.
And then we are passing that along with the query and the prompt. And then we
Right.
are generating the response. So this
Right.
entire thing is known as retrieval augmented generation
Okay, understood.
because we are retrieving and then that is helping us generate the response.
Okay, thank you. That was my question.
Okay.
And Prabhuji, if it was fine tuning in the same diagram, this context will not be passed, right?
Fine tuning, let's keep it separate. Let's not worry
Okay.
about fine tuning.
So just one more question. In your diagram, you are using the word SageMaker. So what SageMaker is doing? Like what is the role of SageMaker here in
It's
this?
just a compute environment. Okay. That's it. So don't worry about what is SageMaker for now. Just think
Because we
of
have
it as a server.
yeah, a few years back we were using this SageMaker, then we have stopped using it. So, but behind the scene we were already like I was not doing, but our similar team they were using it. So that's the reason I just want to know what exactly it's
No,
doing
so
here.
it is just like a server endpoint. Okay. Nothing more than that. It can be like you can be using something else as well.
Okay.
Hey, just to add context on SageMaker, it's an AWS service which is used to deploy and host your models as well. By deploying and hosting your model, that can also provide you endpoints that can be called from your code.
Right.
So you have Azure endpoints, you have like GCP instances, okay, Google Cloud Computing instance. It can be anything. It's just a compute environment, okay, a cloud
Okay.
compute environment.
So basically, we can put any model behind it, and it will just help
You
to.
can host any
Oh,
model, okay, and use as an LLM, okay, and wherever you want to, okay. It can be any cloud service provider.
okay.
No, I'll have to read about Notebook LM, okay, how does it work? Probably they are also using RAG and uh, should be using RAG, okay, but not really sure, okay. Okay, so if some of you are more interested in reading about RAG, okay, and also understanding some of the limitations of RAG, I'll recommend reading this paper.
The screen sharing stop, Prabhuji, if you're
Yeah,
sharing.
yeah, I've stopped it
Okay,
because it
okay.
was not let. So I was not able to see who was speaking, so I had to stop the screen sharing.
Oh, okay.
Okay, so look at this paper. Okay, this is not a very old one. The work was done in 23, but got published in 24. And here, like we all highlighted some of the limitations of RAG, okay, where context retrieval fails, okay. And then how do you address that? So it's also available on archive. So if you just search for this, you'll find it on, because on archive you can just download it for free. Means here I think you have to pay. Okay. Yeah, it's on archive as well, so you can just look at this. Okay. So yeah, with that, let's wrap up today's session. I hope now RAG is, means you will all will be able to tell, okay, what is RAG, okay, and what is the role of context in this, and what is the role of embeddings model in RAG, right?
Good, Prabhu. Thank you, Prabhu.
Yep. Thank
Yeah,
you for
thanks so
taking
much.
time and staying late
Yeah, it's
for
already
this.
12:30 or 12 o'clock,
It's
12
12, yeah,
midnight.
it's 12.
Yeah.
And yeah, probably I'm very jet lagged, okay. So, yeah, next week when we meet, I'll be in better energy and spirit.
No, no. Thank you.
Yeah, you can
Thank you,
check the
Prabhuji.
time
Thank
too.
you.
If you feel that it might be a little early, should be fine for you.
Time
Yeah,
is
you tell
fine
us the time,
actually.
Prabhu. Whichever time
So
works
this
for you,
time is
tell us.
fine because like I have to put my kids to sleep. Okay, so
Okay.
they are not asleep before 11 in the night. So time is
They must
fine.
be having jet lag like you, so probably next week scenario will change.
Let's see. I'm not sure.
Yeah. Anyway, whatever your time works for you, please let us know.
Yeah, yeah, sure. Yeah.
Hare Krishna. Thank you, Prabhuji.
Okay. Hare
Thank you.
Krishna,
Good
everyone.
night.
Hare
Yeah.
Krishna.
Good
Yeah.
night.
Yeah.
Hare
Thank
Krishna.
And
you.
everything I am uploading, okay.
Hmm.
So if you still have questions, you can look at the recording later on.
Okay.
And I remember someone was asking in the group about some project also. So we will do a capstone project as a part of this, but I'm not sure, okay, because how many of you would really opt for it? Because not everyone is attending all the classes. Like there are some of you who are attending all the classes. So if you are attending all the classes, like through all the classes I have been telling, okay, like giving some of the ideas related to capstone. One could be like doing some fine tuning. One could be like building a RAG based system. Okay. I think last week itself I was discussing with one of the Prabhu that we can build our own chatbot. Okay. For temple. Okay.
Yes,
By putting
yeah, we
all
were.
the Bhagavad Gita.
I was discussing with you.
Okay, Prabhu. Yeah. So like that is one nice project. Okay. That we can do. I think it will be a great service to the temple because in that case we won't have to really depend on ChatGPT, right? Means we can use some open source language model and host it, okay, which will be far cheaper, okay, than using ChatGPT.
Yes, Guru, that sounds very good project.
Yeah. Okay.
Thank you, Prabhu.
Thank you.
Okay. Hare Krishna,
Hare
everyone.
Krishna.
Thank
Hare
you.
Nice.
Krishna. Hare Krishna.
Hare Krishna.
Hare Krishna.
You're going to stop recording, right, Prabhu?
Yeah, it will stop on its own.
Okay.